does using scientific notation help when computing with very large or very small numbers? Think about this question during the lesson. This graphic shows the relative size of the Earth and Moon. Here is the approximate mass of Earth and the approximate mass of the Moon. How much greater is the mass of Earth than that of the Moon? What does the exponent tell you about the magnitude of the number? You can immediately compare sizes of two numbers by comparing the exponents. Although 7 and 35/100ths is greater than 5 and 97/100ths, the exponent in Earth's mass, 24, is greater than the exponent in the Moon's mass, which is 22. This shows that Earth's mass is the greater number. One way to solve the problem is to write the two numbers in standard form and subtract. 5 and 97/100ths times 10 to the 24th power, when written in standard form, looks like this. That's a lot of numbers. And 7 and 35/100ths times 10 to the 22nd power is written like this in standard form. Now subtract. The difference is about 5.90 times 10 to the 24th power. The solution should be expressed with the same number of significant digits as the measurement with the least number of significant digits. What is the disadvantage of using standard form to subtract these two numbers? The numbers have a lot of zeros, which take time to write and are difficult to keep track of. Another way is to write the two numbers with the same power of 10. Notice that we can use a property of exponents to write 10 to the 24th power as 10 squared times 10 to the 22nd power. We can rewrite the number 5 and 97/100ths times 10 to the 24th power to 597 times 10 to the 22nd power. Now subtract the two numbers. We don't know what the next two digits of this number are. We can assume they are zeros, and our answer will be reasonably accurate. The difference is the quantity 597 minus 7 and 35/100ths times 10 to the 22nd power, or 589 and 65/100ths times 10 to the 22nd power. The last step is to convert the difference to scientific notation. Remember, the first factor must be greater than or equal to 1 and less than 10. Write the difference with the same number of significant digits as the measurement with the least number of significant digits. The difference is about 5.90 times 10 to the 24th power kilograms. Now you know how to add or subtract two numbers written in scientific notation. The planet Venus is on average 2 5/10 times 10 to the power of 7 kilometers from Earth. The planet Mars is on average 2 25/100ths times 10 to the power of 8 kilometers from Earth. When Venus, Earth, and Mars are aligned, what is the average distance from Venus to Mars?
So we need to rewrite our numbers. So I'm going to take the 10 to the 8th power and going to make it 10 to the power of 1 times 10 to the power of 7. I want it to be the same exponent as the other numbers. So I have now 10 to the power of 1 times 2 and 25/100ths, and now that becomes 22 5/10. tenths. This will be a decimal. Okay. And times 10 to the 7th power. Now we have 2 and 5 tenths times 10 and 7 tenths plus 22 and 5. Let's get 2. 22. Why is it not doing that? Okay, 22 and 5 tenths times 10 to the 7th power. And so 22 and 5 tenths times 10 to the 7th power. So 2 and 5 tenths times 22 and 5 tenths is 56 and 25 hundredths times 10 to the 7th power. Made a mistake. I multiplied instead of added. Again, when you rush, you make those simple mistakes. So this should be 2 and 5 tenths plus 22 and 5 tenths, which is equal to 25. And then 25 times 10 to the 7th power. I want to go back to having that 10 to the 8th power. So I'm going to make this 2 and 5 tenths times 10 to the 8th power. And that's it.
The Confederation Bridge connects New Brunswick to Prince Edward Island. The main part of the bridge rests on piers that form 43 segments. What is the approximate length of the main part of the bridge? Express your answer in scientific notation.
Write the expression to represent the situation. So we have 8 and 2 tenths times 10 to the power 2 times 43. That's the segments. And then 8 and 2 tenths times 2 times 4 and 3 tenths times 10 to the power 1. And remember, we changed that because we wanted to have the same, so we're going to have to change the exponent. So we're going to multiply the 8 and 2 tenths and 4 and 3 tenths times 10 to the power of 2 times 10 to the power of 1. And then you're going to add the properties because you're multiplying. So that's going to be 3. And then you have this multiplied equals 35 and 26 hundredths. And so 35 and 26 hundredths times 10 to the power of 3. But the first exponent we have here, we want to go, let's see, it's square. So we want to have this in, where there's only one digit before the decimal. So we're going to, by moving over that decimal, our exponent here increases to 4. So the length of the main part of the bridge is approximately 3 and 5 tenths times 10 to the 4th power feet.
A queen ant lays 1 and 83 hundredths times 10 to the 6th power eggs over a period of 30 days. Assuming she lays the same number of eggs each day, about how many eggs does she lay in one day? Express your answer in scientific notation.
First, write 30 in scientific notation. So 3.0 times 10 to the power of 1. There are 2 significant digits because terminating zeros in a decimal are significant, and terminating means it does not continue, it stops there. Then divide. So we take the 1 and 83 hundredths times 10 to the 6th power of eggs that she lays and divide that by the 30 days, which is represented by the 3.0 times 10 to the power of 1. So they wrote it as a fraction, the division as a fraction. And then you take the the power tens, and then you divide those, and you take the numbers and divide those. This equals 0 and 61 hundredths. And then the quotient of powers property means that when you're dividing, you're able to subtract them. So 6 minus 1 is 5. And so the first factor must be less than 10 but greater than 1. So that's why we need to move the decimal to the right. And by moving it to the right, to make that a 6.1, our exponent decreases. So we have 6 1/10 times 10 to the 4th power. So the queen ant lays about 6 1/10 times 10 to the 4th power eggs per day.
There are 1 times 10 to the 14th power good bacteria in the human body. There are 2 6/10 times 10 to the 18th power good bacteria among the spectators in a soccer stadium. About how many spectators are in the stadium? Express your answer in scientific notation.
Let's begin to solve. So we have the good bacteria in the human body, and we have the good bacteria among the spectators at the soccer stadium. So we're going to divide these to find the number of spectators. And so we have 2 6/10 times 10 to the 18th power, and I'm going to show this division as a fraction. So that's 1.0 times 10 to the 14th power, and the quotients of the power of quotients law is when you're dividing the exponents, you can subtract. So then this will be rewritten with 18 minus 14, which would be 4, and then I have to divide the 2 6/10 by the 1. And so my answer will be 2 6/10 times 10 to the 4th power. And that's it.